Okay, the title of my research proposal is called How Does Food Water Activity Affect the Shelf Life of Dehydrated Fruit? This is for Diet 400. A little background information on food dehydration dates all the way back maybe to the beginning of time. The dehydration of fresh fruit and vegetables have been used for many centuries, dating before the invention of refrigerators and freezers. People had to use sunlight and wind to dehydrate food, which would allow them to have food from one season to the next. So during these times, people didn't have the elaborate technologies that we currently use today, and so they had to most so use natural ways to preserve their foods to get them through long winters, after harvesting their food, maybe in the summertime. So they had to either dry the food out with the sun, or they can use wind, or they can use smoke from fire, where air circulation from fire smoke would enter different fruit, vegetables, or meats, fish, herbs, and that would help them to basically lower the water activity before that probably was even a term back in the day. So this was how they done it back in the days before all the technology was introduced to society. And so we go to the next slide, which what is food water activity? And by definition, water activity is the ratio of vapor pressure of water in a solution compared to the vapor pressure of pure water. So in other terms, or in layman terms, basically water activity is the amount of water or the percentage of water that's found inside of different foods, with mostly fruits and vegetables containing a higher amount of water activity than, say, a piece of steak or a piece of fish. So when you take a fruit like melons or watermelon, for example, those fruit are full of water, and they have a water activity level of 92%, which basically says that 92% of a watermelon is water. While evidence shows that it's better to consume raw, unprocessed fruit and vegetables daily, there's a high probability that a lot of people not going to do this. And so what happened was people came up with other ways to get people to increase their food and their fruit and vegetable intake. And so they've done that by introducing food dehydration. Sometimes they would use food coating to coat foods to lower the water activity, and other things. In addition to that, Americans typically waste a lot of food. On average, it appears that Americans waste about 133 billion pounds of food every year. And so another thing with food water activity is that by fruits and vegetables containing such high amounts of water in them, they typically have a short shelf life. So some fruits and vegetables may last on the shelf 2 days, some may last all the way up to 4 weeks before they begin to spoil. So in a nutshell, that's what food water activity is, and this paper will talk about in detail how we can control food water activity to extend the shelf life to basically make the food last longer. Next slide. Okay, so we'll go to modern day American society. And nowadays we have advanced our technology with the Industrial Revolution. We have advanced agriculture processes where we have all types of different machinery that we use for farming. Um, and so these things have really helped people in society, the technology, especially in America. And we have a lot of different companies that, made life very convenient for us. For example, like, people have Uber, Lyft. Um, you even have cars that have autopilot option where people can have their car to drive them and they can just sit back and relax and just enjoy the ride. But when it comes to ready to eat food consumption, a lot of Americans have become more conscious, health conscious, and they typically want their fruit and vegetables to be readily available for their convenience while they constantly are on the go. So, because of these fast-paced American lifestyles, uh, these new trends has caused the demand for dehydrated, ready-to-eat fruit and vegetables to increase. And because of the increase in demands for dehydrated, ready-to-eat fruit and vegetables, food manufacturers have been pacing to keep up with the demands. So they have to boost supplies and dehydrated, ready-to-eat fruit and vegetables so that these foods can be available for consumers and also to preserve fresh fruit and vegetables throughout the year so that the demands can be sustained. But preserving fresh fruit and vegetables isn't easy. And so in order to accomplish this, there are several processes that has to go into dehydrating fruit to lower the water activity to prevent microbial growth. And also a lot of attention has to go towards preserving healthy bioactive compounds and nutrients that's found inside of the fruit and vegetable to maintain the integrity of it for the health benefits that they provide. So the purpose of this research is to study the water activity inside of pineapples and also elderberries. For the pineapples, we're going to analyze the water activity at 25%, 50%, and 75%, and also a raw pineapple, which typically has a water activity of about 85%. Afterwards, the pineapples will be analyzed and we're going to evaluate microbial growth within the pineapples to basically predict how long the pineapples can stay on the shelf in the store. So as a result of this research, I hypothesized that the pineapples with the water activity level of 25% is going to have a longer shelf life than the water activity at 50%, 75, and 85%. And so now we'll go to our first lit review. And this lit review has to deal with uh, food spoilage and this experiment that was done with Eurotrium species. So in this study, the authors they studied the water activity and temperature on the growth of Eurotrium species and it was 4 different species that they studied, the 4 most prevalent ones, and they studied them at different temperatures, and they use malt extract agars range with a water activity ranging from 0.71% to 0.99%. And so the growth and development of the fungi species, they typically change the organoleptic and nutritional quality of the fruit, and that essentially affected the shelf life of it. So we'll go to our next lit review, and in this experiment, the shelf life of minimal processed pineapples were experimented on, and they use edible coatings to preserve the pineapples. In this experiment, the pineapples were basically cut into a 1/4 of an inch cubes, and then they submerged the pineapples into different aqueous solutions containing distilled water, calcium chloride, citric acid, ascorbic acid, glycerol, pectin, tarragon, xanthan, and they also had a control group of pineapple that didn't have any coating, so it was just raw pineapple. After the pineapple pieces were dipped, they were placed in plastic jars, and they were stored for 12 days at about 40 degrees. They then evaluated the pH, the titratable acidity, soluble solids, the mass loss of the fruit, and they also evaluated microbial activity. And the final results of this experiment indicated that edible coatings were efficient enough to maintain and conserve pineapples, and the pineapple pieces that they treated with the tarragon had basically the best results out of all. And so now we're going to go to my actual methodologies for my experiment that I'll be doing next semester. And I'm going to be taking a raw pineapple, and wild crafted elderberries, and I'm going to be drying these 2 fruit using 2 different techniques. So for the pineapple, I was going to use the food dehydrator in the food lab in Go Hall, but I can just use a conventional oven to do my experiment. With the elderberries, I basically harvest some elderberries about 2 weeks ago, and I let them air dry. I let them hang and air dry in my kitchen, and so I'm letting those dry out. So I won't be able to change the water activity of the elderberries, but with the pineapples, I can heat them and heat them to like attain like different water activities of 25%, 50%, and 75% by adjusting the different times that I'm going to be using. And so with the raw pineapples, I purchased them from a local grocery store, and again, the raw elderberries will be dried inside my kitchen. So I'll take the raw pineapples and I'll cut them into 1/4 of an inch pieces with a knife, and I'll place them into the oven separately. I'll cut the pineapple, cut off the stem, cut off the skin of the pineapple, and then I'll place pieces into maybe on a piece of aluminum foil, place them in the oven, and then for the